Effective precipitation is equal to the difference between total rainfall and actual evapotranspiration. In this example, learn the impact of effective rainfall in the derivation of a unit hydrograph. You are in hydrology. The third example involves a watershed of 50 square kilometer area. The storm produced 1.5 centimeters of effective rainfall for a 2-hour duration. A streamflow hydrograph is measured and we are to determine the direct runoff hydrograph, the 2-hour unit hydrograph, and to check runoff volume consistency. Let's plot the hydrograph with 12 Qmex on T0, followed by 20 on T2, 55 on T4, and 90 on T6. This is the peak discharge. The other coordinates are 65 Qmex on T8, 30 on T10, and 12 on T12. Getting back to the problem, it states that baseflow is assumed linear, where the direct runoff ends when the recession limb returns to pre-storm flow. This implies the flow before the storm, which is at T0, with discharge of 12, which means the end of direct runoff is also at 12, which is at T12, showing that the base flow is constant throughout the curve. Next is to generate DRH. From the graph, we can continue completing the direct runoff by subtracting the base flow from the discharge, and since base flow is constant at 12, the direct runoff then starts with 0 at T0, then 8 at T2, 43 at T4, 78 at T6, then 53 at T8, followed by 18 at T10, and ending with 0 at T12. To compute for the volume of direct runoff, take the area below the curve. There are 6 partial areas. However, we can use trapezoidal rule to shorten the computation, which was presented in the first example. The trapezoidal rule is a numerical integration method, which you have learned in numerical solutions. Trapezoidal rule is an area determination method, but the area from the hydrograph is taken as volume. The volume then is half of the interval, which is 2 hours. Then take the dr lengths starting from 0 at T0, then twice of 8, 43, 78, 53, and 18. Then ends with another 0 at T12. The volume then is simplified as 400 cubic meters times hour upon seconds, where we use the conversion factor of 3600 seconds per hour, canceling time units, and giving the volume of 1,440,000 cubic meters. Knowing the volume of direct runoff, we can compute for the runoff depth by dividing it by the catchment area, that is 1,440,000 cubic meters, divided by 50 square kilometers, which is converted to meters with a factor 1,000 meters per kilometer. The depth is then 0.0288 meter, taken as 2.88 centimeters. However, if we review the premise, it is also stated that effective rainfall is 1.5 centimeters. So which shall we use to determine the unit hydrograph? Let's make it clear that runoff depth is the totality, including losses due to evapotranspiration and others. So since the premise provides the effective rainfall, we use it to compute for the unit hydrograph. UH is then taken as direct runoff divided by effective rainfall, starting with 0 for T0, then 8 over 1.5 is 5.33 for T2. 43 divided by 1.5 is 28.67 at T4. And 78 upon 1.5 is 52 at T6. Next is 35.33 from 53 over 1.5 at T8, and 18 upon 1.5 giving 12 at T10. T12 is again 0. This is the 1 cm unit hydrograph from the storm. Note that for the case of the first example, the effective rainfall wasn't provided, so we estimate the unit hydrograph using the runoff depth. The next requirement is to check consistency of runoff volume. The expected runoff volume for a 1 cm rainfall is taking the volume from the catchment area multiplied by the depth of 1 cm. The volume is then 50 square kilometers multiplied by 0.01 meter, giving 500,000 cubic meters. The computed unit hydrograph volume is the volume of direct runoff divided by the effective rainfall. The volume is 1,440,000 cubic meters divided by 1.5 cm, giving 960,000 cubic meters per centimeter of excess rainfall. This is for you to try. A 3-hour storm with 2 centimeters effective rainfall is observed over a watershed of 80 square kilometers. You are to determine the DRH using linear baseflow separation, ending when the runoff returns to pre-storm flow. You are also to derive the 3-hour unit hydrograph and to check volume consistency. With similar procedure as the example, you should have the peak discharge of 122 cumex per centimeter for the unit hydrograph, and the volume of direct runoff is 3,348,000 cubic meters. Good luck!